Welcome everyone, it's Jess from A2UK, and thanks for joining us for today's webinar, Autodesk Fusion 360 for Collaboration and Data Management. Applications Engineer John Pitcher will be presenting for us today. So before we start, we'll just go through about A2UK, all about fostering innovation through consulting and training. A2K Technologies plays a vital role in helping the infrastructure, building, mining, construction, architecture, and manufacturing industries reach their full potential by delivering technology solutions and support services such as education and consulting. We work with visionaries to shape the future of design and in turn enable them through innovation to minimize risks, improve productivities, and achieve excellence. A2K Technologies is considered business partner of choice and trusted advisor by vendors and clients. We partner with major software and hardware vendors to meet their clients' technology needs. We strive to exceed client expectations by pinpointing their challenges and delivering solutions through experience and innovation. We work with clients and companies of any size nationally and abroad. Over to you, John.
Dexter, and welcome along, everyone. Just a quick sound check there. Dexter, you can hear me okay?
Yep, all good.
Fantastic. Thanks for that introduction. And yeah, welcome, everyone. It's great to be able to present for you today. My name's John Pitcher, as Dexter's mentioned. And it's great to have you along to today's webinar. So just a bit of an introduction on myself first up. I'm presently working with A2K Technologies as an applications engineer, mainly focused in the mechanical space. My background is in the mechanical sector in various aspects of manufacturing, including CNC programming, hydraulics and pneumatics, machine design and manufacture. And for the past 15 years or so, I've been connected to the Autodesk line of products. And more recently, I've been focusing and exploring the concept of additive manufacturing, or what we commonly refer to as 3D printing. Not so much for printing trinkets and things like that, but more involved in printing for manufacturing. So just with regard to today's webinar, is about one of Autodesk's fantastic little CAD systems or applications called Fusion 360. And I like to refer to it as the new kid on the block, so to speak. It was developed some time ago, back in the mid-1990s. But as you're probably aware, many of the other CAD systems available today were developed well before that, perhaps even 10, 20 years before that, with AutoCAD perhaps being one of the older or earliest developers in this space, going back into the 70s, actually, and the early 80s. So why is that important to what we're talking about today? Well, for those of you that can remember back into the 1980s, we were still working with dial-up internet, and sending files that were 100 kilobytes sometimes took minutes when we were working with dial-up email and dial-up internet for our service transmission. So back in those days, Australia Post was nearly faster than our data transmission. But certainly things have changed, and as we'd all be aware, obviously the whole concept of high-speed internet has been with us for 10 years or so now, and we're obviously reaping many benefits of being able to share large amounts of data and work with larger data sets over an internet-based system. And I guess the big thing about that is that Fusion was developed alongside of this internet revolution. And consequently, what Autodesk have done is included a good many tools that wouldn't have been possible or even thought about back in the 80s and early 90s. So we see some really great developments in that space, and certainly being able to connect and collaborate is a very important part of what Autodesk have done with the Fusion 360 tool. And certainly over the last 18 months or 2 years since the COVID challenges have been with us, there's been a need for people to work in more connected environments and to utilize more fully some of these more cloud-generated tools. So I guess as manufacturers particularly, we're being forced to rethink about things that we design and the systems we use to integrate with other people and other stakeholders in business and clients and customers and other aspects of what our businesses do. So I guess we need to have a system that, to put it in one word, needs to be very agile. we need a system that is flexible and gives us greater adaptivity to work with multiple systems within perhaps a cloud-based situation, when we've got people working from remote offices and working from home and all other manner of situations in between. So one of the biggest challenges in the past decade is really just the amount of data that we're required to create and also consume and share with designers and manufacturers. And that can present some real challenges. So being able to collaborate seamlessly is critical to design and production. And this is where Fusion 360 really shines. And certainly many options that we have within the Fusion space to be able to communicate design changes and design developments without being connected to a physical server or a company-based server. But obviously, we're linking a lot of this information now through cloud servers and things like Google Drive and all sorts of other systems of sharing data online. And so having connected data is quite a critical thing for us to explore and to be able to utilize. So what I'd like to do is drill down a little bit further during today's webinar and just look a bit further at how some of these tools can be utilized by designers. And what we'll do in a little while, all going well, we'll jump in and do a quick live demo on some of the tools available to us within the Fusion 360 environment that allows us to integrate and work with cloud scenarios. So what I'd like to do, well, just a couple of little things about Fusion for those of you that may not be aware of Fusion. I like to refer to it as Inventor's little brother. So the Autodesk Inventor tool has been around since the early 90s and even the late 80s. They started developing the Inventor software. But again, not developed so much in line with using cloud type systems, where the Fusion tools have been developed very much with that in mind, that high-speed internet is now a thing, and certainly we're able to utilize that. So just a couple of little things about the Autodesk Fusion 360 space. It basically is a cloud-enabled CAD system. It's you may have heard of a number of the other systems that Autodesk use. There's AutoCAD 360 nowadays with an online version of AutoCAD. We've got BIM 360, Drive 360, A360, and basically a lot of these apps are dependent upon you being connected to the cloud. Fusion is a little different in that we do have the option to operate in offline mode, meaning that we can save our files to our local drive quite easily, and then at periodical times we can go back in, connect to the internet, and reconnect with design changes that might have been made by other stakeholders in the business, and we can work collaboratively in quite a logical fashion. So basically, the concept with Fusion is that, like I said, we can save files locally, and I'll certainly touch on that as we jump into our demonstration in Fusion shortly. Another really powerful feature of Fusion is that it's not limited to being run on Windows systems. So Fusion itself can quite happily run natively on a Macintosh machine. So for those of you that are of that desire, if you like to run Macs, there's no reason that you don't have to install Parallels or Boot Camp or whatever for allowing you to work on a fairly high-end piece of CAD software. I guess the other big thing with Fusion is it's not just a CAD system. Fusion has a number of other aspects to it, in the sense that we have a CAM workspace for doing computer-aided manufacture. So if you want to go in and do some CNC programming or CNC toolpath design, we just switch into that workspace, and I'll certainly explain that shortly when we jump over to Fusion. There's a number of other tools in there as well for doing renders and even simulation, so we can do some stress analysis and a number of other elements of that. And again, a lot of these are based on utilizing cloud servers to perform those functions in a much quicker way. Roughly a tenth of the time that it will take your local machine to do a process, because obviously we've got an access to an Autodesk server bank that has huge processing capability, much more than you would ever see on a local machine. So I guess the big thing with Fusion is because we're linking into numerous other tools and numerous other elements for our CAD design and CAM functionality, we're linking into cloud servers that can certainly allow us to have greater productivity and ability to perform functions perhaps not available to us. Yeah, if we went back even just 10 years, there's a lot of functionality that has now been added because we can transfer large amounts of data from an internet connection very quickly. So Fusion itself has some other very powerful little elements to it in the sense that it now has a sheet metal module where we can create flat patterns and of sheet metal cutouts. We can also create things like exploded assemblies. So for animating perhaps a work instruction or an installation of a particular piece of equipment, we can certainly do that quite easily in the Fusion interface. Fusion itself also has some very powerful surfacing tools. So we're able to work with T-splines and NURB surfaces, and we'll certainly be chatting about that. So I'd like to chat just for a moment or two, and I'm sure we've all perhaps heard or at least read of the various industrial revolutions over history, and I find this an interesting subject. I won't bore you for too long if it's not something of interest to you, but as we look through history, there's been what we commonly refer to as 4 major industrial revolutions. So yeah, basically the first revolution actually happened way back in the 1700s and early 1800s. Basically, manufacturing evolved from focusing on manual labor performed by people and aided tasks that even animals were used to produce in the forms of optimized labor. So basically from there, we've people started to use water and steam powered engines and other types of machine tools. The second industrial revolution was basically in the early part of the 20th century, where the world entered a second industrial revolution. And basically that was with the introduction of steel and the use of electricity in factories, the introduction of electrically enabled manufacturing processes to increase efficiency and make factory machinery more mobile. It was during this phase that mass production concepts like assembly lines were introduced as a way of boosting productivity. So the third industrial revolution, very interestingly, in the 1950s and 60s, slowly began to emerge as manufacturers began incorporating more electronics into their systems, and eventually computer-aided technology was entering factories. And certainly during this time, manufacturers began to experience quite a large shift and put an emphasis on analog and mechanical technologies and more digital technology and automation of their software. So the fourth industrial revolution, or what is commonly referred to as Industry 4.0, in the past few decades, this fourth change has taken place. And the emphasis with the fourth digital or industrial revolution is around the digital technology. And certainly we've seen quite a number of leaps ahead, if you like, in the way that we use technology to help us create things. And certainly towards the end of, well, more recently, the whole concept of IoT or Internet of Things, where we can access real-time data, and the introduction of things like cyber physical systems and a number of those other phrases that we're now seeing being adopted in the world. And yeah, so we've basically seen quite a lot of interlinking and holistic approaches to manufacturing. And basically what it does, it connects the physical and the digital and allows for better collaboration and access across departments, with partners, with vendors of a product, and people generally. So Industry 4.0 is really empowering business owners to better control and understand every aspect of their operation, and allows them to leverage instant data to boost productivity, improve process, and drive growth within their particular scenario. So Fusion itself is very much part of this revolution, I guess, in that sense, in that Fusion is a very data-orientated system, but it's also a very cloud-orientated system where we are able to collaborate very effectively with large groups of engineers and designers and people throughout our system and make that, like I mentioned, more of a holistic approach to an overall look at the way our CAD system functions. There's a whole range of processes within that. And what I'd like to do today is explore some of these processes and look in more detail at a number of aspects of the Fusion interface. And certainly one of the important areas of this is the Fusion data panel, which I've got there on screen at the present, and certainly being able to save files to your cloud storage area, a bit like you would in, like I said, Google Drive or Dropbox or any one of those other systems. But Fusion does this sort of automatically for you in the background, and it does it pretty flawlessly. So we don't need to do anything special. It's, yeah, like I said, just as easy as using Google Drive or any of those other tools that are available to us, but it's interlinked with your CAD system. One of the other really important things with this is that all of our revisions are tracked and saved. We don't have to check files in and out or anything of that nature. Basically, as we move a design forward, we can see the history of that file and look at the way that that is all functioning. Our designs aren't broken or anything like that as we work with all of these collaboration tools. So we can obviously set up a system of data management within our cloud storage area, and Fusion will very happily link to all of those elements and allow us to work with each of those items. Like I said, we can work offline. So if you do happen to be working in an area where you don't have a reasonable internet speed or a connection or whatever it might be, we can certainly work with our files in offline mode. Once we connect back up to the internet, obviously the files are all re-uploaded and stored back into your cloud storage, and you're back and connected as you would expect. So yeah, we can obviously go for a period of roughly 2 weeks without connecting to the internet, and eventually after that, Fusion will start reminding that you should allow it to back up your files to the cloud, and certainly work with that. Now, a lot of people that I come across, and certainly in defence organisations and things like that, there's quite always a bit of concern about how secure your files are. And I've popped the link in the bottom of this slide here where Autodesk actually explain their compliance to having trusted data and some of the various aspects of that. There is an international standard for this now, and Autodesk do certainly tick all those boxes for having a reliable system of internet security, and yeah, certainly ways of making that work. So what I'd like to do now is swing over to Fusion and have a quick look at how the Fusion interface behaves, and just explore some of these tools that we've got for collaborate and for different elements of our collaboration tool. So what I'd like to do is quickly head over to Fusion and just explore that particular some of those particular tools. So I've got a little Fusion design here, and what I'd like to do is step you through the process we might use and how we can work with that. Like I said, a very important part of Fusion, I've just got a simple little vice assembly here that I've modeled up, and effectively with Fusion, for those of you that aren't aware, we have not unlike most of the CAD systems, we have a browser here for how our model is created, and obviously it lists all of the components. One other little interesting thing that may be a little bit foreign to some of you is the timeliner down the bottom left here, which is basically the order in which each of these features were created or added to the assembly in this case. So this is assembly, or a group of parts that have been added together to create a list of some of those or that group of components. So what we've got in Fusion, as I mentioned, the data panel, which we can hide and show. Obviously, on this left side here, we've got a whole bunch of tools for working with different projects. So you might either set up a project per customer or per job, depending on the nature of the way that that you'd like to use Fusion. And we can certainly do that just by adding a new project here. And then we can certainly have a bunch of different files or whatever it might be that that we might look at using or utilizing as we move forward with our inventor data. So for instance, if I was to go into this A2K Fusion 360 training project that I've got available here, if I simply double click on that, you can now see a whole list of files here. I can have subfolders for separate files created in each of these particular situations. So this is just a list of files, I guess, that we might utilize for this particular project. And again, we can share information with other people within the industry. So, so if you're working on a particular project, we can obviously invite other people to join in on that project, and they have access then to the data that is stored here, including things like notification of updates or different elements of working with that. So there's quite a few different settings that we've got in here as to how we'd like to work with Fusion. Obviously, we've got a search option at the top where we can search through all of our projects or a specific project and chase down files as needed. So the data panel is sort of, I guess, your gateway, if you like, to where your files are stored and where you're able to create a group of files that might perhaps work in that sense. So this particular little device assembly that I've got here in this folder here consists of these 8 or 10 parts, and effectively in here I've got some information on the individual components. So here's each of the actual part files that are included in my vice assembly. Now, if I was to explore this to the right, the bottom right of each of the files, you'll notice I've got a version number. So each time a file is saved, Fusion prompts us to give it a basically a status or a save. Perhaps you want to save a note with it to say that you've made such and such a change. So every time we do that, we can see a history of our files being created. And if I was to click on this little version history here, it would tell me if I went through here, I've got 8 versions of my vice that have been saved over time. And you can see all of that history as to when we worked with this particular file and how we actually went about using it. Now, inside this version area, we've actually got some other very helpful information because we can have a look here of the subcomponents, a list of the items within my vice assembly. It also tells me that if I've used this particular vice in another major overall assembly, it would tell me that it's linked to that assembly. Okay, so there's quite a handy little bunch of tools. I've also got a connectivity here to a drawing that was created for this particular vice, and we'll certainly dig down on some of these as we work through our demonstration today. So, like I said, the data panel is a very important part of Fusion 360. Basically, it's a link to an Autodesk storage area where your files are saved on an Autodesk server, cloud server. And we can obviously have multiple of these storage areas. So I get one because of my Autodesk account. So I've just called mine my initials and my Fusion 360 drive area where I've got access to that particular account for maybe the team that I'm working with or collaborating with on a particular project. Now, as I mentioned, Fusion itself is Yeah, a very powerful little system. Like I said, we can work offline with Fusion. And you'll notice up in the top right of your screen, up here, we've got a series of little buttons. And the one that I want to just point out is this little clock face. Basically, what the clock face tells me is that I'm currently working online. And if I was to turn this off, Autodesk Fusion would just simply say it's working offline. And then when I went to save my files, rather than default saving them into the cloud or into my data panel area here, it then gives me the option to save them locally. Okay, so I can set up a standard sort of a folder structure on my C drive or on a data drive or whatever, however you'd like to save the files locally. And when we're offline, those files are saved to that area. The other really clever thing about this as well is we can cache a bunch of information. So as if for some reason we're suddenly locked out of the internet, maybe your internet at your company goes down and the IT department are working tirelessly to resolve that. Obviously, during that time, you want to be able to continue working. So the Fusion system can be set up to cache information in the background, and we can certainly see all of that information happening as we work through that system. So yeah, quite important that we understand that Fusion can be used in an offline mode. Something that that a lot of people aren't aware of. A lot of people back away from Fusion because they think, well, what about if I do happen to have a glitch with my internet, or if all of a sudden I don't have access to my internet for whatever reason, although that's becoming a fairly rare occurrence these days. But still, there are times, I suppose, where you may wish to work in offline mode, so as your data, and like I said, your data can be stored locally using that little function. Now, as far as Fusion goes, one of the other sort of fairly significant differences is that we have 6 or 8 different options here for different environments. So the Fusion space, if you like, I'm just in the design environment at the moment, but as you can see in this little drop down here, we've got an assortment of other spaces, if you like. And we can quite happily switch into these different spaces as we need. As I mentioned before, one of the other ones that I just briefly mentioned there was the manufacturing space, where we can go in and create some toolpathing. So if you've got a CNC machine or a laser cut machine or whatever it might be, we can certainly just go in and switch to that mode. And when we do that, and I'll just quickly jump over here, you'll notice now we get quite a different menu of information, which is orientated around CNC. So we've got milling, turning, additive, et cetera, for 3D printing, fabrication. So we've got options here to create laser cut profiles or whatever it might be in that particular space. So in the manufacture space, we're able to switch into an environment that allows us to generate, and we'll probably at the end of the day, an NC program or a G-code program to generate toolpath for our particular manufacturing situation. Now, this one doesn't, well, it does use some aspects of cloud, but some of the other areas that are much more widely generated around cloud usage. So in here, you might have noticed we've got a render option. And when we switch into render, basically the render situation allows us to render. As you can see, I've got some interesting shadowing going on here with this particular device. I haven't set this up at all at this point, but effectively when we render, we use an Autodesk server to do the render. For any of you that have done rendering in the past, you know that it is very processor intensive and will probably hog 90 or 100% of your RAM, and certainly your graphics card will be working extremely hard during the period of that process. So much so that frequently, if you do run rendering, you'll not be able to use your machine for anything else. Now, that's obviously a bit of an inconvenience, but with Fusion, we're able to do this on a cloud server. So effectively, we upload the render process. The render happens on an Autodesk server. And then following that, once the render is completed, in roughly 1/10 of the time it would take you locally, so the render process happens on an Autodesk server in much shorter time frame than it would if you were running it locally. And then you just basically, it will send you down a message to say that your render is complete and that you can now download the render and use it. Now, there's quite a bunch of other tools within the Fusion space that use that same sort of functionality. Okay, and yeah, certainly we're able to do that and to work with those particular elements. But what I'd like to do just briefly as a matter of course, and just to show you how this versioning system works, we'll come back to a couple of these other spaces a little later on. I'd like to just briefly mention generative design, which is another very interesting part of Fusion space. This generative design area here, we'll certainly touch on that a little later on as well. But what I'd like to do, just as a matter of course, and just to show you what happens when we make a modification to a particular file, for instance. So I've got the body of my vise here. And as you can see, it's got some tapped holes and some countersunk holes and different things around. But when we look at this particular file, and look, we could do all sorts of edits, but what I've chosen to do today is just to add a decal to the side of our little vise here. So I'm just going to add a little image. And as you can see, once I do this, we do this via the canvas options here. So this would be all local processing, but effectively I've picked up a PNG graphic and I'm just going to place that onto the side of my my little vise here. So quite easy to be able to manipulate and work with this graphic. So I'm just popping it here on the side of my my vise, just as a little graphic, or like a decal, I suppose you might call it. So yeah, once we've placed that onto our vise, and I perhaps could have been a little bit more careful of my placement there, but effectively when I save this file, Fusion says to me, well, what do you want to do? Do you want to give this a name? So I'm just going to add here decal. Okay, added to our part. So we added a decal there. And I can add a milestone as well to this. So I can set this as a like a particular time frame. But yeah, effectively, I'm going to pop in here that this is a new version of this file effectively. And what you'll notice now, this is currently at V4. But once Fusion does its save, and apologies for the bandwidth, my Zoom meeting is probably taking up a little bit of time here, but ultimately, as you can see here now, it's switched over to version 5. Now, if I was to go and click on version 5 here, Fusion would show me below the recent items that I've made change to. Okay, so in here, some time ago, I also changed the texture. There's a number of other changes down here that have been made as this particular file maybe was edited or changed according to that. Now, if I flick back into my vise assembly, you'll notice now, and I'll go back into the design area for this one, just to save a bit of bandwidth. My decal is actually missing at this point, but you'll notice in the browser you've got here something has changed, and it's, as you can see, it's saying that there's been a modification to the body component. So it's highlighting the fact that this file is out of date as such because I've made a change to one of the components. Okay, and if I was to right-click on this this little line up here where I've got this information symbol, I've got an option to update the particular referenced files. So if I click on here, Fusion goes away and looks at the different files and says, okay, something has changed. And again, apologies for the time this is taking. Normally it would happen at the blink of an eye, but you can see there now Fusion has updated the body file, and I no longer have that little warning to say that, that my file has changed. Now, the great thing about this, if I was, for instance, to open an exploded view, or if I was to go into the animation area of Fusion, again, here's my vise in its exploded state. So I've just pulled the parts apart there, but notice again, my decal is automatically updated in all of these particular files. Okay, so yeah, quite a useful little situation there. As you can see, we can see that update has taken place across each of those components. It will also have taken place at the drawing level. So the great thing about this, and look, most 3D CAD systems will do this when we make a modification to one part. Once we update that part, obviously the all the associated files are updated accordingly, and we can work with each of those files. Okay. So we've got a couple of drawings here. Again, just simple part drawings and drawings which are giving us access to see each of those objects. And again, that's just another part of the Fusion interface. So this particular space here is, as you can see, it's obviously where I can create working drawings and drawings that are maybe ready for production via this system here. So if I go into the drawing area from my current design, it would allow me to create a drawing of the body of my vice component. So Fusion has quite a clever system of being able to store all of that history in a cloud type situation, and allows us to maintain connectivity with all of those files that are utilizing those particular designs. Now, as I mentioned earlier, and look, I don't want to take too much of your time today, but one other little space that I find really interesting, and this is obviously quite a growing area, is this generative design space. So the generative design space inside of Fusion is quite a powerful area, in the sense that when we go into this area, we have the option to maybe look at a design. So this little caster is an example of this. We've got a caster with a support bracket here that's supporting the axle for our wheel, and also has our mount post. But effectively, what this system allows us to do is to interrogate that design digitally and via the computer's processor to look at perhaps other iterations that might be acceptable in the sense of having the same structural strength, but by reducing waste or reducing the amount of material. Now, obviously, this functionality has been used for a good number of years inside of the CAD, especially in 3D CAD systems. And companies like Boeing obviously have been using this logic for many years to make their aircraft lighter and lighter. Obviously, every kilo of extra weight that you need to get off the ground, you need to carry so many liters of fuel. And then for those liters of fuel, you need to carry extra fuel to get that fuel off the ground. So the aircraft and aerospace industries have been very interested in this space for 20 or 30 years. And we've certainly seen some fairly, and perhaps even longer. So they've been using algorithms that allow them to digitally interrogate their model, so as they can see where they can reduce waste, and certainly for aerospace, where they can reduce weight of particular products. Because if they can save material, they certainly save quite a lot of excess and things like fuel then to get those particular items off the ground are not needed. So this is not a new technology by any stretch, but it's certainly new in the sense of being cloud orientated. So what Fusion, what has happened in the general Fusion space is that what we're able to do now is create these generative design studies. Now, as I said, going back 20 years to do these sorts of things, your software would have cost you well over $100,000 per seat to be able to do this. But now these tools are in the hands of everybody, because they are so much cheaper for us to utilize and make use of. So being able to create these generative studies allows us to interrogate our model and look at how we can effectively save waste from our product. So I'll just close out of that. I'm a bit conscious of my bandwidth at this point, but I do have a little example here, and I'll just switch over to this little clevis design. Again, a fairly simple design that maybe is used to hold a hydraulic cylinder or something like that on perhaps like an excavator arm or something of that nature. So here's a very traditional design that we've been using for many, many years. So a fairly standard clevis. We've got some bolt down holes, and obviously a shaft would go through here, or a pin that would support one end of, yeah, maybe a hydraulic system to an excavator arm or something of that nature. So what we've actually done, and I'm just going to, again, I can't really run this due to bandwidth, but and I don't want to interrupt the Zoom session and have our Zoom session time out. So I've got a couple of little slides here on this particular process. So if you can imagine, we're going to bolt this clevis to a part of our excavator with these 4 holes here, and then yeah, we're going to put a pin through here. Basically, what we do in the generative design space is we set up forces and loads, and we tell Fusion that we're holding this clevis in place with these 4 particular holes, and then we put a load on this journal here. So, you know, if you're picking up a ton of dirt at so many meters of extension, your hydraulic cylinder may need to have 4, 5, 6 ton of pressure at this particular journal. So what we do, we set up a study and preserve some regions and things like that. We set up a bunch of obstacle geometries. So in here is basically what we're going to create to allow us to look at the way that our clevis could be designed in a more appropriate fashion, mainly by reducing the amount of waste. The customer obviously doesn't want to pay for excess material. So how can we better utilize our software to do that? So effectively, we run this study over our particular model, and after we've set up those different joints and things like that, which again isn't tricky to do, but yeah, effectively then we generate the design study using certain criteria. So maybe by default, this particular bracket might weigh, let's say, 4 kilograms or something of that nature. What we do is we tell Fusion that we want to reduce it down to 1.5 kilograms, but we don't want to sacrifice that load rating based on these 4 mount holes and this journal having X amount of load on it. Okay, so yeah, quite a fancy little process. So I've just got a couple of screen grabs here. So effectively, if you can imagine, we're using these 4 bolt down holes. Here's our journal that's got the load on it, and we set up these regions, if you like. What Fusion then does is comes back with a study, and this is actually exactly what we've got there in the sense of these 4 bolt down holes and then our journal with the load on it, and it will produce a 12 iterations of different designs that we could use to then reduce the amount of material we're using in this particular clevis design. Okay, so yeah, in actual fact, the concept is this is all done up on a cloud server. So the cloud server analyzes the model and says, okay, if you want to preserve the 4 bolt down holes and the journal where you're going to mount your hydraulic cylinder to, these are the outcomes from that, if you like. And look, it's very quick to do this actually if you're running off a reasonable internet speed, but we process that and allow that system to process, and then it comes back and says, okay, well, here's some final results. Do any of these suit your particular need, or what particular look are you wanting to be able to create this particular part? So as you can see, if we run this through, basically the original design on the left there, we run it through the system in Fusion and tell it to generate the part file. We selected the one at the top there, and then basically we can 3D print this particular part on, and A2K have a fancy little metal 3D printer, so we did actually print this part out. We told the part that we wanted it to be under 1.5 kilos, where this original sort of shape was 4 kilos. So we lost a couple of kilos of weight, which, hey, mightn't sound a lot, but when you're using a clevis maybe 10 times, over you've got one on each end of your hydraulic cylinder, for instance. And you've got maybe half a dozen of those hydraulic cylinders on your excavator arm. For every one of those, you might be able to pick up X amount more product or whatever it might be. Now, obviously, this particular situation has been not uncommon in the aerospace industry, like I said before, but was much, much more costly to generate. So, like I said, nowadays we've got access to this software at quite a cheap cost, if you like, and we can start doing these same studies and looking at how we can improve our production processes and reduce weight. So yeah, effectively we're now finding this being quite widely used in the automotive industry. So here's an example of a General Motors part that is actually now being 3D printed. So previously, these seatbelt brackets were actually created from 8 components. So there was some pressed metal components, obviously, some folded components that all did different things. But what General Motors were able to do is look at this process and say, well, if we go from here to here, we're not using 8 components. We're not having to create machinery to assemble those components, because effectively we're now able to create that as one particular part. So again, it does come down to shortening that design process. Obviously, it's quite quick to create these prototypes and do some testing on them. But you can see there the example of that particular bracket, and yeah, not sort of using traditional manufacturing methods, but again, we do have access to either CNC equipment that's capable of generating programs for these sorts of tools now using our CAM tool. We don't need to sort of look at traditional materials or traditional sort of methods of manufacture, because now things like 3D printing have changed a lot of that space. So yeah, effectively there's a group of iterations that were developed or that came out of a 3D CAD system and were available then to be selected with regard to that. So generative design is a very important part of the manufacturing process that we're seeing develop these days. Obviously, it's been around for a couple of years now, but we're finding it being honed and made more appropriate for use, and certainly work with that. So yeah, generative design is certainly another tool that is cloud-based and cloud collaborative, in that sense of linking to your original Fusion design and allowing us to create those simulations to look at things like load ratings and cost reductions, weight reductions, et cetera, And so aside from the tools that we've discussed today, there's a bunch of other cloud tools, like I said, for data management as well. You may have heard of a product called Fusion Lifecycle, which is another tool that allows us to manage our data, our Fusion data. There's also some Vault elements that link with Fusion, which can be quite handy, and maybe that's a topic for another day. Obviously, that's going in at another level and looking at a little bit more detail, working with the Vault interface and the Fusion space. But really, that's what I had hoped to present today, and just give you a bit of a heads up on how we can work with some of those elements. And I really enjoy using Fusion. Fusion is a very powerful little tool because of its multifaceted system and its ease of collaboration. So like I said, keeping information shared to the right people is quite a simple and easy process with Autodesk Fusion 360. So I hope you've enjoyed today's presentation. It's, yeah, like I said, it's a very exciting space to be in. There's a lot of development going on that can really help us move some of those functionalities forward. So yeah, we've got a couple of minutes now, so feel free to ask questions either via the chat system on your Zoom window, or equally, if you'd like to get in touch with us, I'll pop an email address up on the screen shortly that will yeah, give you access to some of the other elements there. So if there's any questions, feel free to pop them into the chat window in the Zoom session. I'll try and answer those now. If I can't answer them immediately on hand, I'll certainly take your question on notice and email you back a a response as we go through there. So just one or two other things about working with A2K, and we'd certainly be very keen to partner with your business. And yeah, we obviously do these webinars on a whole range of different topics. So if you're in the AEC space and you're using BIM 360, we run frequent webinars and items on each of those tools as well. So including things like AutoCAD, Inventor, et cetera, et cetera. So watch this space. We do many webinars in regard to that particular area. So yeah, thanks for watching. Like I said, I'll stay online for a couple of minutes if there is any questions, but feel free to get in touch with us at that email address, info@a2ktechnologies.com.au. We'd be more than happy to chat with you and assist with your needs for working with any of the Autodesk products, or yeah, helping you manage your data or whatever your query may be. So thanks for your attendance today, and appreciate you joining us, and have a great day ahead and stay safe. Thanks, Carl, for your question there on the limit to the number of teams. I don't believe so. I'd have to double check that, and I'll take that on notice and come back to you on that one, Carl. Very good question. How many teams can we physically create? And certainly an easy way to transfer files between teams as well. So collaborating across multiple teams, and I know that your business has a requirement to do that. So let me take that one on notice, Carl. I'll come back to you with a definite answer from Autodesk on that. I don't believe there is a limit, but really it probably more comes down to the amount of storage, which incidentally, by default, yeah, most people, when you take out an Autodesk product, you get a 5 GB storage allowance, which you can obviously up by purchasing extra space on the Autodesk servers. But yeah, thanks for your question there, Carl. I'll certainly take that on notice and come back to you on that one. I don't think there is a limit, but yeah, let me chase that up for you. So yeah, thanks again for attending today, and stay safe, everyone, and we'll look forward to chatting with you when our paths cross again.